August 12, 2026. Europe will darken under a total solar eclipse not seen in decades, a moment that could redefine a generation's relationship to the sky, but the path to this rare eclipse is lined with meteor storms, planetary alignments, and a shadow geometry unfolding since January. Why does darkness return now, and what secrets will the year's unfolding calendar reveal? January begins with a rare double feature in the night sky. On the nights of January 3rd and 4th, the Quadrantids meteor shower reaches its sharp, fleeting peak. For just a few hours, under the right conditions, up to 120 meteors can streak overhead each hour. Astronomers measure that burst with the zenithal hourly rate, written ZHR, a standard that estimates the number of meteors visible in 1 hour when the shower radiant is directly overhead and the skies are perfectly dark. The Quadrantids radiant lies in the northern constellation Bootes, and the shower's brevity makes it a challenge. Most years, only dedicated observers under clear, moonless skies catch the full spectacle. Each meteor is a fragment from the asteroid 2003 EH1, burning up as it collides with Earth's atmosphere at over 40 kilometers per second. For those willing to brave the cold, the show can be intense, silent flashes and sudden fireballs tracing across the winter sky. Just days later, another astronomical alignment takes center stage. On January 10th, Jupiter reaches opposition. In astronomy, opposition means a planet stands directly opposite the Sun as seen from Earth. Jupiter rises at sunset, sets at sunrise, and shines at its brightest, magnitude -2.9, dominating the night. Through a telescope, its cloud bands and the Great Red Spot appear crisp, while its 4 largest moons line up in ever-changing patterns. Opposition is the best time all year to observe Jupiter, as it appears largest and closest in the sky. These January events set a rhythm for the months ahead: bursts of meteor activity, planetary alignments, and shifting windows of darkness that invite regular attention to the sky. Each month will bring its own window, each with a different story written in shadow and light. For now, the year's astronomical calendar opens not with darkness, but with sparks, meteors flaring, and a giant planet rising to claim the winter sky. February 17th marks a rare alignment of shadow and orbit. The moon slides across the sun, but its disk is too small for total coverage. Instead, sunlight forms a blazing ring, an annular eclipse, visible only along a narrow path over the southern Pacific and Antarctica. Researchers stationed in these remote regions will witness the full spectacle, while most follow from afar, drawn to the mechanics behind the event. Unlike a total eclipse, the moon's umbra never touches Earth. Only the antumbral shadow creates that perfect ring of fire, a fleeting geometry that highlights the layered structure of eclipse shadows, the dark umbra, and the lighter penumbra. That same day, Saturn's rings align edge-on, as seen from Earth. Over several weeks, the planet's iconic rings seem to vanish, reduced to a razor-thin line. This ring plane crossing, occurring every 13 to 15 years, offers astronomers a rare chance to measure the ring's true thickness and observe Saturn's moons as they weave through the invisible plane. The planet's 27-degree tilt means these moments are brief, and even powerful telescopes struggle to reveal the rings at zero tilt. March 3rd brings a different shadow play. The full moon enters Earth's umbra, producing a total lunar eclipse visible across Europe, Asia, and the Americas. The moon glows deep red as sunlight, filtered through Earth's atmosphere, reaches its surface. It is the first total lunar eclipse visible across Europe since 2015, likely drawing families and skywatchers outdoors. Seasonal change arrives with the March 20th equinox, balancing day and night. For astronomers, it signals shifting skies, longer nights in the south and shorter nights in the north. Mars brightens steadily, becoming a prominent evening presence by mid-April, drawing attention from those planning telescope sessions. By early summer, anticipation builds. lodging demand spikes in eclipse paths, especially in northern Spain and Iceland, as travelers prepare for August's totality. The evolving interplay of shadow and tilt shapes both the sky and human plans. August 12, 2026. Across northern Spain, Iceland, and the Arctic, the light begins to fade in the late afternoon. Temperatures fall, shadows stretch and sharpen, birds grow silent. In the towns along the center line, from Oviedo to Burgos, streets fill with visitors who have traveled for this moment. At the edge of totality, a veteran eclipse chaser stands with his daughter, recalling the rush of 1999 in France, when crowds packed the fields and the sky broke open for the first time in a generation. He checks the horizon for clouds, a weather app in one hand, a solar filter in the other. He says the anticipation is the same. But now, I know to watch for the beads of light and to have my camera ready. The last sliver of sun disappears. For just under 2 minutes, 1 minute 55 seconds in Oviedo, 2 minutes 18 seconds near the Arctic, the world falls into an unnatural dusk. The temperature can drop 5, even 10 degrees Celsius. The horizon glows with a 360-degree sunset. Bailey's beads flash as sunlight pours through lunar valleys. Then the diamond ring blazes for a heartbeat. The sun's chromosphere emerges as a thin pink arc. Then the corona unfurls in pale streamers, visible to the naked eye. This brief totality is the moment we wait for. A European Space Agency solar physicist stationed in northern Spain narrates the science. He says, Europe's latitude this time gives us a rare angle on the corona's structure. Every image, every second adds to our understanding of the sun's outer atmosphere. Safety is absolute. ISO 12312-2 certified solar glasses or filters are mandatory for every partial phase. Only during totality can filters come off, then the corona becomes visible and the sky turns deep blue. For those photographing, the guidance is precise. Bracket exposures from 1/1000th of a second to 1 second at ISO 100 f-stop 8 to capture the full range of the corona. Wide shots with 200 to 600 millimeter lenses reveal the sun's ghostly crown. Longer focal lengths catch the delicate inner details. A municipal planner in Burgos, overseeing an influx of visitors, explains, "We have prepared for months. The last time in 1999, no one expected the roads to fill so quickly. Now, we want everyone to see it safely and to remember why this matters. As the sun reappears, filters return, the crowd exhales. For many, it is the first total eclipse in their lifetime. For others, it is a return to the darkness last seen in 1999, a reminder that these moments are rare, but shared across generations and borders." On October 4th, Saturn stands at opposition directly opposite the Sun as seen from Earth. All night, the planet appears as a steady, golden beacon in the constellation Taurus. Through a telescope, Saturn's globe is crisp, but its rings are nearly invisible. The edge-on geometry, a result of the ring plane crossing earlier in the year, reduces the iconic rings to a thin line. For weeks around opposition, even large telescopes reveal only a faint, razor-sharp band, while Saturn's brightest moons, Titan, Rhea, and Dione, line up in a narrow plane. This rare alignment, repeating only every 13 to 15 years, offers astronomers a unique window to study the ring's true structure and the delicate shadows they cast. As autumn deepens, the sky's rhythm continues with the equinox on September 23rd. Day and night balance for a moment, then tip toward longer darkness in the north. By December, the year's final act unfolds. The Geminids meteor shower arrives on the nights of December 13th and 14th, peaking with a zenithal hourly rate of 100 to 120 meteors. Unlike the fleeting quadrantids or Perseids, the Geminids produce a steady, reliable display all night long. Their radiant in the constellation Gemini climbs high overhead after midnight. The meteors themselves are slow and often intensely bright, sometimes casting shadows as they burn. Each streak is a fragment from the asteroid 3200 Phaethon, vaporizing in Earth's upper atmosphere at 35 kilometers per second. Even under winter's chill, the Geminids draw observers outdoors, families, amateur astronomers, and photographers alike, hoping for a glimpse of a fireball tracing across the December sky. The calendar closes with the winter solstice on December 21st, marking the longest night of the year. Darkness stretches across the hemisphere, but the sky remains full of stories. For those who have followed the year's events, witnessing eclipses, oppositions, and meteor showers, there is one more way to contribute. A citizen science upload portal invites observers to submit their best images and data, Saturn's vanishing rings, Geminid fireballs, or even solstice star fields. Submissions received by December 31st will help researchers and educators build a record of this remarkable year. In 2026, the sky offers not just moments of awe, but a chance to share discoveries with a wider community, reminding us that every observer adds a new story to the night. In 2026, the sky offers what no screen ever can, a reminder that we share one planet, one shadow, one fleeting moment of darkness. These rare alignments unite millions across continents. The universe still unfolds above us if we choose to look up. What will you see?